Yes, good morning. Uh, I don't know how to go around it. I don't know what to say. If we are starting a new program, or like a new course, or we are starting an old course in a new way. A minute. Sorry. How are we? Yeah, I was making a point. I've been doing the tutorial for some time now, and I have a couple of videos already on YouTube. Some watch it, and then they kind of like it, and they give recommendation. And the recommendation is, it's like I kind of started in the middle of what programming is. Had the videos like I'm just coding in let's say C++ or in SQL Server, and the reason is the whole idea to do this came about when I entered class. So I plan to do a tutorial of all the courses we are doing. I wouldn't have searched for the best, those I know. I'll do tutorials of them, especially those that are related to programming. So I went straight into solving class questions. So I skipped a lot of the basics, like what programming is, who is a programmer, why C++, a bit of history of those things. I skipped all those things and I went straight to solving the class exercises, the midterms and those things. But those watching, they are all of my classmates. People outside are watching and they have interest and they kind of want to get the basics. So some actually suggested like I start from scratch. So that's what brought this whole idea. So the tutorials I've been doing already, but today's one is what the scratch is about. So that is basically what this one will be, and going forward you will see why I chose C++. So this is just the basics for us to know what programming is, who is a programmer, or let's say who is a software developer, what are they doing, how far have we come, like how did it all start, and what tools do you need, basically that. And then let's say who can be, like everybody can get up and say I have to be a programmer. Actually, there is that debate going on, like, because if you kind of read online or you follow the news, it's like everyone is telling everyone to go and code. So are you all going to turn into programmers? So there's that argument too. My one interesting answer I got some time back is, we've all been learning English. Me, for example, I've been learning it from P1. I'm still not the best. I make errors. I'm not an English teacher. I'm not expecting English, but I've been learning it from P1. The important thing is it helps me to understand the world, to understand people, to understand what people say. So in that same scenario, you can learn the programming, though it's not even your field. You at least know the basics to know when computers speak, to understand computers. Because going forward, basically every work will be relying on computer. So if you can understand what is going on, you might not be the guy doing the hard thing, but to understand those things, I think that argument, I like it. So straight away, that is it. We are starting from scratch with the beginner in mind. So the first thing we have to look at is, what are the the resources we'll be using. I'm looking at 3 key resources. One is an online resource from Tutorial Point, and I can say almost everyone in the programming field knows about this site. Tutorial Point. Tutorial Point. Now if you check that out, it's an online site for different computer science related courses, different programming courses. Like for example, almost everything about computing, you get a complete course there, stripped down to the beginner. Very simple. I personally like their courses and the way they structure it. So their course on C++, we'll be using it. Their course on C++, so that is it. We'll be using the resource. Another resource we'll be using is a book. As the title is Object-Oriented Programming with C++. Is that I think some lectures at KNUST, and that is what the computer science department is using for a distance. I don't know if that is what the regular students are using, but I'm aware that is what the distance students are using, and that is it here. This book, so we'll be making use of this book too. Basically, by the end of the program, like this series of tutorials, you should be fine with this book. So that is one thing, like a goal we have to achieve. I just want to go through the writers, course writers. That is Dr. James Hayford Aqua, and he has very enviable credentials. Like his first degree computer science, master's computer science, PhDs computer science. Like everything about him is computer science, and you can see some other universities he works for, like kind of running consultancy services for almost all. He's an external examiner for university for that's Accra Institute for All Nations, for University of Education, for Methodist University, Regent University, University for Development Study, and then for the College Health Science, University of God. So many, and so that is he's the writer, and then the core developer is that also a lecturer at K University. So basically, it's like the computer science department, they team up, led by Dr. Hay from Aqua, and then they did this book. It's very detailed, and I like the content. The content is also basic. I will not say basic, but if you compare it with other books, you realize they've really come down to, if I should say, human level. They've come down to human level. So this was another resource we'll be using. And then the third one, that is everyone's secret. That's Google. I'll be using it a lot. Things. I'm a student, so I don't know everything. So anything we all have to say, we will do it, and then we will move on. So anything at all, if there is issue, we all check it on Google. And yeah, that's it. We move on. So these are the core materials we will be looking at. I think this should rather have been course material. Yeah, something like this. It should have been course materials. So yeah, this makes sense. So these are the three key things you'll be using. Now I told you we'll be starting from scratch. So basically, if you say like programming or like programmer or software developer or it's a developer, what does it mean? They say in simple terms, if it's like you are programming, that means you are communicating with the computer. Let me just put it that way. You are instructing the computer to do something, so you are programming. That is just so you are communicating with computer. Just take it like that. So if somebody is programming, or that means he's communicating with the computer. Another way people normally put it is, let's say here, then they will say he's or she's coding, like she's coding it. So it all means you are communicating with the computer. To do what, that depends on what you want to do. That depends on what you want to do. It could be you are requesting for some information, maybe weather report, maybe satellite data, or pulling some images. So it all depends, and it could also mean you are doing a program like Excel, maybe, or Word, or WhatsApp, or whatever. It could also be you are writing a program, or like you're kind of instructing the computer to do a program that others can use. Yeah, if you take Word or Excel or WhatsApp, for example, I have let's see, this is Word. I am using Word. I am using it. I can use it to print what I want to print. I can use it to type my letter. I can use it to do any design, form, whatever. Now, I am a user, so I'm using it, but someone did it. The person is called a developer. The one who did the Word is called a developer. The one who did the Excel is a developer. The one who did WhatsApp is a developer. It's difficult for one person to do, so maybe they are developers or like team of developers. So whilst we are okay, like for example, this is PowerPoint I'm using alright for my presentation. I'm a user. but someone did the PowerPoint so that we the users can use. So that person is the developer, or that person is the programmer, and like the act of doing is the programming. So he's doing it. The one doing it is a programmer, or others can call him a coder. It's a dirty word, but people use it. He's a coder, or like he's a software developer. Now, if you go into software development, it's actually something bigger than just being a programmer. Like me, I can easily call myself a programmer, but it's difficult to call myself a software developer, because that has to do with some requirement analysis. Have to do requirement analysis. You have to do risk analysis. You have to do a whole lot. It just goes beyond you developing the software. It just go beyond you develop. You have to take a lot of things into consideration to become a software developer. You have the skills for doing it all right, but a whole lot of other things you have to. Even how to manage people, you need it before your software can really work. How to write documentations, technical documentations, user documentations, all those things come into play if you are going into, let's say, software development, or let's say it's a software developer. So but the basic skill you need is the coding, or like the fundamental skill you need is the programming that you have to use to instruct the computer to do whatever you want to do. So basically that is it. If you are instructing the computer to do something, you say you are coding, or like you are programming. It depends on what you want to do, but most of the time if related to you are writing a software, and we know software example is Excel, example is Word, example is WhatsApp, Skype, VLC, literally everything we use on our computer is a software. Calculator, this is a software. So basically that is it. The one who did this is a programmer, or let's say a developer, and to do this, the act of doing this is what is called the programming. So basically that is it. Now the one who does the programming, that he's communicating to computers, he uses a language. If I want to communicate, like right now my communication is English. I can't speak English to computer, or I can't speak English to hard disk. I can't speak English to memory. I can't speak English to any of the computer devices, or like printer. I can't speak English to printer. So how do I achieve this communication with computer, instructing computer to do it? How do I achieve it? I use a language to do it. Take note, I use a language to do it. But you can use English, you can use French, you can use it. Computer has its own language that you also have to learn. So basically, like when we get the ball rolling, we are actually learning another language that we will use to communicate with the computer, not with human beings. So that's what I just wrote here. Take it that in your mind. It's a language you are going to use, and that language is used to communicate with computer, not human being. So that is it. And just like how English has its own rules, this language you are learning to has its own rules. Chi has its rules, Hausa has its rules. This language too has its own rules. Where you have to put full stop, where you have to put semicolon, where you have to write a sentence, punctuations, subject, verb. It has to agree. This language too has, just put it in your mind that way. This language too has those rules, and that is why you have to learn. And when you know that, then you can now communicate with a computer. Now let's go back into time. How did it all start? Like the act of talking to computer or instructing computer to do something is going through so many phases, just if you should call it evolutions. It started, maybe you were doing it X ways, now you are doing it Y ways, now Z ways. So based on limitations of one method, now then there is an improvement, a recommendation, use this method. So basically those are the generations. And if you've done a bit of IT related, you've heard of generations of computers, meaning computers have gone through different phases, different evolution, like from the mainframe to the desktop to now tablet. And so those are the different generations. The programming language too has the same generation. So it all started with machine language. Take note, machine language. So initially, when programmers wanted to communicate with computer, they will use machine language, and that was years back. If you take the book here, you realize that is the first generation, and the communication here, like the alphabets you could use to communicate with the computer. Remember, we are matching this with like normal language. Just have that in mind. So at the machine level, or like that generation, the language or the alphabets of the language you can use are just 1 and 0. In other words, you can call it, or no, you can, that is it, base 2. That is just the language you can use to communicate with the computer. Those times, let's see if we can get the years. Just that, base 2, 0 and 1, there is nothing more you can do. I wanted to see if we could get the years, maybe the period for those ones, but these are things you can Google them out. So base 2, that is for the first generation. So for example, if you want to tell the computer, take typical example, this let me see this pen. Now remember, I typed this thing and it displayed. So if I want to get this thing displayed, let's say I've typed L. Now this is how the computer works. The L will be converted to base 2. The I will be converted to base 2. T will be converted to base 2, and then given to the computer. Now when the computer wants to display it, the computer will pick the L, revert it to L, take the base 2 of I, reverse it, take another the base 2 of T, reverse it. Or if it's 1, if you want to say 3 in the computer, let's get bigger font. Now if you want to say 3 will be converted to base 3, base 2, and then that figure will be, let's assume, is something like this. Then it should be 8. It will be converted to base 2. I said 8 for a reason. We will get to that. So it will be converted to base 2. Then this base 2 will be stored in the computer's memory, or wherever it has to be stored. Now if you want to store 2, this 2 will also be converted to base 2 and then stored. So now you have 32. Now if you want to display 32, now the 3 this is what we have in the computer now. So it will be converted back to 3. Then this will be converted back to 3. Now, the first question you might ask is, so why do you convert, like how can you convert something like L to base 2? Like the little up there. How can you convert LITT to base 2? We know from the maths we've done 0 to 9 we can convert them, or like 1 to 9 we can easily convert to base 2. Now how do you convert things like this to base 2? Now, because of that challenge, what they did was to build kind of a table and then give these letters a code, which is a number. So assuming, let's say L is 30, this is 52, this is 12, this is, that will be the same 12, that will be L, so it should be 30, and then let's say E is 11. So they build this into a computer. Computer has this spreadsheet, kind of like a table, every character on your keyboard and its corresponding number or the code. So if you type L, the computer will quickly go look through the code, pick 30, convert 30 to base 2, and then save it. If you type I, it will go through its table, look for the corresponding code, which is 52, and then convert 52 to base 2, and then save it. Now if you want to display, it will go through the same process. So if you take for example this, or like just what I'm typing here, let's say the boy is good. What the computer just did is took this, mark it to 12. Yes, please come in. Is it? Hey. Yeah, hello. What are you going?
Come check.
Stop here. Boy.
Sure.
Ah, okay, that's fine.
I see some. Please go to 10.
Yeah, that's why Mr. Bude now.
Yeah, so I got somebody.
Nah.
So you take your.
No, we empty now. I mean, here's not actually an office, it's a same room.
Oh. Okay.
But I sick of in the street, and that's one idea. So, yes. Yeah, nothing special. Nothing special. I just did. I do tutorials also. Afterwards, I'll put it on YouTube, like programming.
Which language?
I'll use C++.
C++.
I've already done some on YouTube.
Have you sent me some?
Yeah, some LinkedIn. So to my link go off.
Is it your own? Like,
yeah, long. So yeah.
Let's like I said that download.
Nice. But all this conversation is coming up. They record. But no fee. But if it's some manners where like they watch, where they say like it's fine, but I was doing the class things, so that they want the basis, like from scratch. All I did was class exercise. It's from that level, but some watch and like that they want from scratch. So I should start the C++ from scratch, or like the programming in general from scratch. So basically that is just what I started from here. So the materials I'll be using, I went through what programming is, even who is a programmer, developer, what programming language is, and then this is like scratch. Before finally I'll go and pick C++. I'll pick C++ finally for the coding aspect.
So you use the
this dev.
No, the camera. Web.
Yeah. That's my laptop camera and the use.
Why don't you buy that? The one they put on top. That one be like powerful.
Yeah, that one is powerful, but it's costly. I check it on Amazon. It's around somewhere $100. There are even around $120. That's for the camera. That's for the camera. It's powerful.
You do it up,
You still date up.
That's what they take chop.
Well, it's
like if it is years, I won't start this year. So I set some goals.
yeah, okay.
I won't crash it. By the end of the year, like
I mean, that's fine. It's good to set goals. It's good.
Since I finished, I do that. They take some give my money. Like they ask for money.
That's great. That's great. One of my goals is to get 100 hours of video this year. Yeah, by the end of the year, I want to get 100 hours of. 100 hours.
So you're starting with C++ first.
Yes.
We move to other.
Yeah, I don't know if time will permit where I will reach with the C++. But I'm sure if I'm to cover everything on the C++, that alone should give me the 100 hours. Yeah. And you know, getting a Zongo girlfriend.
Zongo.
Yeah, they love internet things. I'd get some deal from the Zongo ministry to train the Zongo youth in software development.
I mean, the Zongo guys are no, then kwashi boys.
And yeah.
Kubolo. Don't cry, you.
They don't have internet. That is the concept we want to change. I think Zongo should be known for something better.
Yeah.
If you can sit down and memorize everything in the Quran, and then you'll be wasting that brain doing stupid things.
No, it's just ignorance.
It's one of the things I think it was last week, one of my guys, he went to sign the MOU with the Ministry of that is Inner City and Zongo Development.
Yeah. The guy, I forget his name, that fair man.
Hamid.
Yeah,
Mr. Hamid.
Then I listen to some interview. They want to bring them IT stuff.
Yeah.
Then hacking, like internet security things.
We only require the guidelines. In Zongo, you have realized we have that interest, but we are using it wrongly. So if you can get that guideline, channel that, it's like strength. Like the person who gets strength, he get that him say he gets strength. So that type of things, you can channel it to security. You see, the person like they near thing already, so he just there causing trouble. But you can channel that stubbornness into security. Then you kind of control him there, and he'll be a hero. Because let's go get armed robbers, he doesn't fear. You go. So it's just a matter of
you see how even Americans
controlling those things.
Then get those hacking boys and they'll put them in the NCIA, FBI things. They'll just down them in the prisons. See, say you be good at just invest in you. You use your
I have one friend, he's in prison, like hardcore criminal. He's in prison, and what he's learning is how to train security dogs. That's the course he's doing now. So when he comes out, that's the course he'll be doing. He'll be working with the industry, training security dogs. So there are ways to channel things we normally see as stubbornness or
like
bad
behavior. Domestic dogs then.
He will train them to make them wild dogs so that like homes can use them. So it's all about how to
with the mindset
channel. Yeah.
If you make up your mind that you can do something.
You're fit.
the dependent thing, I know they like.
It's no one's interest. Sometimes for hustle.
Sometimes
for hustle. So that is.
Going back, I know some guy. He knows how to sew things like tailor.
Yeah.
Since school days, since he was doing it for then Face of Indies, the ladies.
Okay.
He's the one who does their dresses and we play school now, you know they get job. So of you to focus on that because you were getting money from you didn't got 3 awards when we were about to complete from the university. As in best tailor, like
wow.
Entrepreneur. Now that you have completed, you have all the
you have to focus on
this day there, challenge.
The problem is the system is, I think this thing has to be tackled from childhood.
Yeah.
You
like
see,
when you are done,
as you complete school, someone has to employ you. You need that indoctrination from childhood that grow and do something for yourself. Grow and do something for yourself. We need that ideas from the grassroots.
Banks and things are collapsing. You think big boys are coming. You know you have something to do. It's time.
Yeah.
Right today, Granada is the Anglo thing. Yesterday, he has some even IT crowd. He has some people.
Yeah.
But now I heard you have to be in Obuasi or something, like be born there. That's how they are trying to do it. You see, when they stopped working, those who were working there, they were foreigners. So after I think it crashed, they all left. You see, they left with their money. So there was nothing in Obuasi again.
Yeah.
So now they want to change that thing and make it those in Obuasi.
They should get some quota. Yeah, I think it makes sense. If they have some quota. Or at least if they have to extend it to Ashanti region or even Ghana. Because there are certain job. I'm not under it, no Boise, but maybe you might not get it to Boise. It's Kumasi, you can get the expert or maybe
physical, those who will do the field work, that's a goal.
Yeah,
fine, that one fine.
Yeah.
By the ITs and those
like
geological, those things there. Because I heard they will be building a hostel as in the campus for, I think, I don't know if it's Lagos, but I heard UST. People, so that when they get to, let's say, third year or final year, they will move. Geological and I think geometric engineering.
That really makes sense. Really
like the way when the medical students they get to 4th year, they move to CAD.
Yeah.
And they want to do that. So geological and geometric, then they will move there, complete their final year there. And they do that.
That really makes sense. And I've always been wondering, like, why somebody should come to, let's say, or like should go to Legon or come to Tech, let's say, a great student 4 years. You just become to Tech 4 years.
4 years.
Sometimes they have to push the person to, let's say, BA or to some agric sector.
Agric engineering, then they'll be doing it.
Yeah, that really makes sense. By the time you finish, you get the real practicals you need on the field.
You'll be doing that.
If you have any tools, take it to the field. You learn to get. You're doing geology and you always want to be at office.
That might help. Make Obuasi nice. Sure, the roads, everything.
Yeah, Obuasi Road.
But I pray that. Because there are some little things that are blocking, like the death of the journalists, men's school. You see, those things like an obstacle. Like it's getting in the way, so it doesn't let people see what your vision is, like what you are trying to do.
I remember one guy, I think he's even an NDC guy. I was watching something like that, and he said something. He said like he will just try maybe like just political ways, but if you sit to analyze what he said makes sense. That a lot of the things that are giving MPP bad names, they are avoidable.
Yeah,
MPP is really working, but things that are taking the focus, there are some stupid things.
They're kidnapping.
There's some stupid things. Then they
that's what is shifting the mind of people.
Other than that, Yeah, okay.
The only one there.
Okay.
We were doing some work, some construction with the maintenance people. Also, let's go and check.
Okay.
Maybe tomorrow when
I hear. Okay. Thanks for the visit. Hey, sorry. That's a nice guy. Came to pay a visit. Let's quickly go on. We've seen this topic, what object-oriented programming. Object-oriented programming. We'll get to that later. If I mean to explain it here, we will kind of, we are jumping, but we are using C++. This is another concept we'll get into. So that is it. And I've talked about the materials we will need. I've also talked about what programming is like. You are communicating with the computer. We are instructing the computer. So that communication is what is the programming. So others will say you are coding. So someone who programs is called a programmer. Others will call him coder or like software developer. And I'm saying software developer is that work is a bit advanced and it needs more experience. And sometimes that experience is not even related to computing. You need to know how to, not related to just writing code. You need to know let's say how to go to industry, design questionnaires, ask people what do you want, analyze the risk. Let's say they need this, you analyze the risk. You have to write down specification, the how do you call it? You have the technical specification. You have to write user documentation when the program is done. And then maintenance and a whole lot. That is what makes the let's say software developer. So yeah, like if I even play for football behind my house, I'll call myself a footballer. But if you compare that one to let's say Messi to calling himself a footballer, you realize there are differences. So definitely that is it. I can call myself a software developer, but a lot it really goes into it. One example is the requirement analysis I made mention of. You even know how to even manage people. How to manage people, you really have to have that experience. And some of the things a programmer can do, we use Word. Word was done by a programmer or like a developer. We use Excel. It might not be one person, maybe 2, 3, 18, 20. That's it. WhatsApp, Skype, Viber. Is Viber still alive? 2019. Let me see. Viber. What happened to Viber? My network keeps going off. What happened to Viber? What happened to Viber? Viber is, I mean, it's still alive. Interesting. So VLC, PowerPoint, all these things are done by. So you are basically doing software. That is what these things are. So that is it. And then to write a software to communicate with computer, you use a language. If now I'm communicating with English, I can use English to communicate with computer. I can use French to communicate with computer. I can use Chi to communicate with computer. I have to use a language to another language to communicate with computer. That language is called programming language. Take it like that. It's a language, but that one is used to communicate with computers and maybe some other devices like phone, like smartphones, like printers, like just devices like that. Take note, English has its own rules, programming has its own, language has its own rules too. You have to know where to put full stop, you have to know where to put semicolon, you have to know when to put things in quote, you have to know when your sentence, where your sentence ends, you have to know your verbs, you have to know your nouns, you have to know your statement, you have to know your compounds, statements, sentence, logic and reasoning, like if Kofi is a boy and Amma is what, then type of thing. You know them all. So that is what programming language is about. And this is where we were. It all started with machine language. Previously, this is how people were coding. Excuse. Hello. I hire a different room. I hire a server room, Mr. Ibo. Hey, everything. Okay. How computers started, like how programmers started writing, like communicating with computers. The first ways, that is the machine language, or like call it the first generation. We know in compared to the generation, like first generation, second generation, from the mainframe to the mini frames to desktop to smartphones. Yeah, so that the language also evolved. The first one is the machine, and the machine is the direct communication with the computer. And that is where we were, and my friend came. I earlier said if you want to save 3 in a computer, you have to convert the 3 to base 2 and save the base 2 in the computer. Now, if you want the 3 back, you convert the base 2 version back to base 10 and then you display it. If you want to save 2, you convert the 2 to base 10. If you want to display, you convert this back. Now, if you want to save something like this little bit, or like the L, how do you save it? how do you convert it to base 2? That is what brought the idea to create a table and then give all letters numbers. So we have L will have its code. Let's say 30. We are assuming we can actually look that up. It's called ASCII table. ASCII table, and then that's the American Standard Code for Information Interchange. That's the full meaning. American Standard Code for Information Interchange. So this is a typical example. So this is something like this. Will be trying to zoom it. Why is it not zooming? Something like, something like this will be in the computer's memory. So let's see T. This is T. The decimal code, the code is 84. So here T is 84. This is also T. So 84. The L. IJKL. L is 76. So L is 76. I is 73. E. And then E is 69. So if you want to save L, or like if you want to save the word little in your computer, or if you want to display it, now if I type L, it's already displayed. But what has actually happened is the L, the computer has picked the L, map it to 76, and then convert 76 to base 2. That is what has happened. It will first, if you type L, it will look for the code that it corresponds to from this table, from the ASCII table. Now after doing that, to convert this to base 2, this is what the computer can work on. So basically that is what it is for all the characters on your keyboard. Now because of this table, take note, 3 is not converted directly. 3 also has its code in this table. So if you can realize 3 this is can we find 3? Yeah, the decimal numbers. I'm going to say 3. 3 is end of tests. Okay, so here we are looking at this 3. This is 3 is 51. So 3, the code for 3 is 51. The code for 2 somewhere here 50. So we have 2 is equal to, where is equal to 2 is equal to 50, and 0 is 48. Let's 0, the code for 0 is 48. So if you type 0 on your keyboard, the computer will look through this table, pick 48, convert 48 to base 2 and save it. This is machine language base 2. So if you want to instruct with the computer in base 2, then you should know number base 2 very well. And basically every time you'll be typing will just be something like this. Everything, this is how you'll be communicating with the computer. 0s and 1, 0s and 1, 0s and 1. Because base 2, the digits are only 0 and 1. So this is just how you'll be communicating with the computer in those days. People have done this. Now imagine if there is a mistake or there has to be a semicolon here. You can't just come and bring it here. You have to look for semicolon, check it in the table. What is the code for semicolon? This is semicolon, and then the semicolon is 59. So semicolon is 59. So you convert 59 to base 2. Yeah, boss. Sure, boss. That is July 2019. Okay. How quick? Yeah. Okay. I hear, boss. Okay. Sorry. I'm still in office time, so these interactions will be like, I don't know if I should call it distractions. I think that's the correct word. It's not disturbance. So where were we? Yeah, so if you want to put the semicolon, this is it, base 2. This 0 something, I don't know why it's doing this. So this is 0. So this is how you put semicolon. You can just put semicolon and it will work. Okay, so now if I scroll back and come, if like I go down and come, where do I even put the semicolon? You don't know. So too much trouble. No, they realize this is not helping. One, it will make you slow too much. It's so too difficult to even find errors when communicating with computers like this. Let's say if you write where you have to put full stop, you didn't put it, and the computer didn't understand. To go back and put full stop is a problem. So then they move, or like they evolve to the second language, and the second language, there is some kind of things make sense. Now, for example, in the first language, if I want to type 3 plus 2, the answer is, let's say 3 plus 2, that's 5, right? So That is, in the first one, you convert 3 to base 2 plus, you look for the corresponding code. No, you look for the corresponding code of 3, and then corresponding code of 3 is 51, so you convert 51 to base 2. Now 2, you look for the corresponding code of 2. 2 is 33, 2 is 50, so you convert 50 to base 2. So you convert, you add those two decimal numbers, the binary numbers. You look for the code of the corresponding code of 3. Let's say assuming is this something like this in base 3, in base 2, that is 3. Now what is the corresponding code of 2 in base 2? So let's say we have something like this. Now you add these ones. Now to add, the sign is this. You have to also check for this one, the code of it, the code of this, the code of this, plus 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 plus, the code for plus, the code for plus, small letters. Where is that? That is it, 43. So the code for plus is 43. So you convert 43 also to base 2. Now you do this addition, the 5, this is equal to, you also search for it. That is it here, 61. The code for equal to is 61. So you convert 61 to base 2. Your answer is 5. The 5 you get, that one to still be in base 2. So basically there is no easy way. This is how you have to do things. Then you say no. So the next generation, that is the second generation, made things a bit easy. Instead of this add, you can use the word add, and computer understands that word. Instead of subtract, trying to find the ASCII code of minus, you can use the keyword minus, sub, and to understand. If you want to multiply, you can use the keyword mul. If you want to divide, you can use the keyword dive, and it's kind of better than this. And this one, you don't have to convert it to base 2. So it's like if this is the computer, so this is the assembly, this is the machine language on it. This is the machine language on it, and then the assembly, the machine language. Then on top of the machine language, now we are having assembly language. So we are now having assembly language on top of it. So the add, the sub, the multiplication, which is mul, the div, etc. They are called mnemonics. I hope the spelling is right. This is for UK, and then in US is mneu mnemonics. In US to be something like this, and then the UK begins with P. So assembly language, you make use of at this level. You can check the spelling. Mnemonics, internet. Actually, this is US, and this is US. This is UK. The PNEU is UK, and this is US. That is spelling. So assembly language makes use of mnemonics. And get this picture right. What it means is assembly language is sitting on top of the machine language. You see, we were typing the zeros and ones, zeros and ones, zeros and ones, zeros and ones here. Now it's difficult. Let's say this is the 2 plus 3 is equal to 5. It's likely to be longer than what I've just typed. So this is 2 plus 3 is equal to 5. Now we come here, then we get 2 plus 3 is equal to 5. So instead of this one, it will now be add to things like this. It's got to add, what have I typed? Let's clear that. So it's got to 5. So this is it. So it's a layer on top of the machine language. Now here comes a challenge. The computer doesn't understand it. This is the only thing the computer understands. Computer only understands machine language. So if you write something like this, you have to find a way for the computer to understand it. You, the human being, can understand it, but the computer can't. So you will have to find a way for the computer to understand what you have written. So you need something that will convert this one to its corresponding machine code, and that thing is called compiler. It's another small software that after writing your assembly language, after writing something in assembly language, it will convert it to a code machine will understand. That is the assembly language. So if the advantage is human readable compared to this, it's clear. You can see 2 plus 3 is equal to 5. This makes sense, but this doesn't make sense. But this is what the computer wants. Computer don't want this. So you have to get a compiler that will change this one to this. Compiler is a software that changes what you have typed. Technically, you can call it source code. So it will change what you have typed, a source code, to a language the computer will understand, which is the machine code or the machine language level. So basically that is the second one, the assembly language. In fact, there are programmers who are just working on this. This is just where they work, and going forward you will come to understand why they still prefer this. There are more ways on top of this. Now if you come here, then you have higher language, or like so this form this is second generation. And this is first generation. So here will be third generation, but others have stopped moving here. They just remain here, and this is just how they communicate with computer, typing things like this. Now if you come to the third generation, which is this one, the third generation, or the high level languages, these are ways to communicate with the computer. Now get the whole thing from first generation to whatever generation you will come or you will find in a book. The main focus is things you'll be writing. This nonsense we wrote here, they are trying to make it better for human to understand. They are trying to make it closer to human language. That is the whole thing, trying to make the computer able to understand human language directly, instead of just typing this nyama nyama. This is what the computer is able to interpret. This is not good for human. So that link they are breaking, like they are kind of merging that what human can understand and what computer can understand. They are trying to find a common ground, and that is what is leading to this second generation, third generation, fourth generation, fifth generation, sixth generation, whatever generation you come across. That is just the purpose. Try to get something like, if you type what is the sum of 5, what is the sum of, let's say 2 and 5, the computer should be able to tell you instantly. Yeah, but also
I agree.
I respond.
You didn't hit inside it.
I forget so. So this is what this higher level of languages, this is what they are trying to achieve. They want the computer to understand. If you type something like this, you should know what you mean. This is higher level language, that is human. So the higher you go on this generation, the more closer what you write, what you tell, or the language you communicate with the computer get close to what human also understand. So basically that is it. So then the third generation also comes to examples of them are here you need some kind of compilers to work with this, like the tools you need. There's one problem with this one also. You can write something for, let's say, Intel 32 processor and expect it to work on another processor. It's processor specific or like architecture specific. If you learn, let's say, X way to communicate with the computer, you can use that, let's say, computer of Intel 32 architecture. You can use that same language to communicate with, let's say, another manufacturer, another processor manufacturer. You can use it. So you have to be specific which language you are using. And here, from what we explain here, what you need to work with at this level is this compiler, so that you type and then to convert it to something the computer will understand. So example of those ones are, we can have I think NASAM, MASAM, TASAM, and we have GAS. This is network-wide assembler, and then we have the Microsoft assembler. We have the T is for more. Let's rely on our third resource, assemblers. Let's see, assemblers. I made it large. Let me reduce the size. So 10. So that is those are the ones you have to use. If you type, let's say, 3 add 4, it will convert it to the zeros and ones, then the computer will be able to interpret. They are called assembly. There are different types. These are the types I put here. I just want to get the full meaning of those nonsense. So, and now from there we are at third generation. We come higher, closer to human being, and what we are going to, the level of program we are going to learn is the third generation, which is a bit closer to human being. We will go into fourth generation specifically here, and then fifth generation. No, we are not getting there. We are not getting there. Now, one thing is, right after this, you should be able to pick up wherever you want to. Right after this, you should be able to pick up wherever you want to. For me specifically, this level is this is the time I'm now learning it, the assembly level language. This is where I started, and this is what I've been doing all my softwares in this language. I'm now learning this one, like going back to you might ask, why do I have to go back? And the reason is simple. The more you go back, the more clear you get to understand, like the more clearer you understand the computer. Yeah, that's it. It's like let me say, going to buy takeaway. That's what you used to do. You know, takeaway. You know, like fried rice. You know, fried rice. You know, fried rice. Then you say no. Now I'm going back to a level where I also have to cook fried rice. So you realize when you do 1, 2, 3, 4 cooking, then like when someone is selling, you have more understanding of what fried rice is. So that is the whole thing of going back a bit into time to understand what happened, how those programmers suffered. So that is it. For here, I will not try the zeros and ones. No, I love my life. I will not go there. So here it is. Let me see if we have something to display. Assemblers. I know this one is the netwide assembler. That is this netwide assembler, and then Massam. This is from Microsoft assembler. Yeah, this is Microsoft's assembler, and then the TASAM. Yeah, that is table. Yeah, the table assembler, and then there is GNU assembler, and that is what is called the gas. The G is for this, and then A assembler. So that is it. Then there is this one too, which is abbreviated as gas. So basically, those are the type of things you need if you want to program, if you want to communicate with the computer at this level. And like I said, all these one types, there are different types for different processor architectures. So that is why you have to know. You can write your code here to work here. So then the higher level of language is here, and then the fourth generation, then the fifth generation. From here moving to here, and it's sometimes even confusing because you find some books, they will combine all this and then call them higher level. They don't go into the, let's say, the fourth generation, the fifth generation, because sometimes if you take typical example, Python and then C# or C++, basically you are dealing with the same level of things, but some books try to split it, take PHP to fourth generation, SQL to fourth generation. Others to the fifth generation, you might go more into human interface, like where you just use tools to do what you want to do instead of going down here typing things yourself. So this is just some rough history, and this book specifically has a lot of interesting things in it in terms of where we came from, the machine language. Yes. A lot of history things here we can go into. These are the generation and how computers started, A, B, very. And the zeros and ones I talk of at the machine level, they are just actually it's like transistors. You know, you can on it, you can off it, or like true, false. They are like Boolean. They have only two states. Like that's why they use 0 and 1 to represent. But inside computer, it's actually current you are dealing with. Or if, like low current, high current, or low voltage, high voltage. So it's full, it's half. So things like that. It's full. Is it charge? Is it discharge? Just two things. So if in your I think I have one video. I'll recommend that, and then we move on. I actually did with 32 and 64-bit computers, and I really explain these ways computers store information in base 2. It's here that you can, this is memory I've kind of, and you can see I've opened the same ASCII table. That's the same ASCII. So I'll encourage you to read this video and to make things clearer so that we can move on. So that is basically what it is. Then we move to, these are the examples I was using. Add, you can see add here, you can see type here, you can see sub here. So basically that is how we are going. This is the machine. There are different instructions you can. Now this is what I use. This is the table I use, the ASCII, the one with code, and then you have to, there are another ways of creating it that is not ASCII. Now if you take ASCII has up to 128 characters. 1 is a character, 0 is a character, 2 is a character, 10 is a character, no, to 9, it ends at 9. Like 90 is just 9 and 0. So there are different ways of representing that. So it's up to 9, And then there is A is a character, capital A is a character, small a is a different character, dash is a character, full stop is a character, backslash, that which way backslash, and then forward slash, column, semicolon, they are all characters. So ASCII support the ASCII table that it has to do lookup. It supports up to 128 characters. Supports up to 128 characters. So if you are just typing English names and other things, you realize that is supposed to, you can do a lot. Literally, you can have every character on your keyboard with a percentage and other things. Now, come to think of it, if you want to type French characters, those type of E and then there is some dash on top, or like, and you can have a dash heading top and you can have a dash coming down. So these are all different characters. Now let's jump further. We want to type some Arabic characters. Now we want to type some Chinese, some Latin characters. Then you realize the ASCII 128 is limited. So there are different ways of encoding characters. Another one is this EBCDIC code. You can find the full meaning somewhere. I will not bother myself. And that supports up to 256 characters. So maybe you can add some other languages. Then there is the Unicode, and the Unicode supports up to 65,536 different characters. So basically, this can let you deal with a lot of different languages, a lot of different characters. This book goes further to explain, let's say, if it's machine language, what are the importance of using machine language to code? What are the importance of using the higher language to code? Machine language, this chart is very important. Keep it in mind. If you are coding here, you are directly connected to the hardwares of the computers. So nothing is converted. Everything you type, the computer interprets it direct. Now, when you come here, you will type, you need a compiler to convert it before it comes here to something that then the computer will use it. That kind of slow the machine a bit. Now, if you come here, that is worse. From here to here. So from top there to here. Now from here to here, the same thing, you need a compiler that will compile it to a level that computers can understand. So if you are typing here, if you are a programmer here, ideally your softwares, but not always, your softwares will be faster than the one who is typing, who is coding using assembly language, and the one here too, his software will be faster than the one here, but the one here suffers more than the one here. The one here suffers more than the one here. So this is kind of trade-off. It's kind of trade-off. So more of that in the book is the assembly language, the second generation they went to and then the advantage, disadvantages. These are the higher level languages. So this is one of these we'll be picking. So basically that is it for you see, they classify the fourth generation as problem-oriented languages, and that is why they put SQL Server, Oracle, or like the structured query languages, SQL. We'll be going through all that. If it sounds like some Arabic things I'm saying, we'll be going through that. Interpreters, assemblers, and then compilers. All this type of software translates. Well. See, these are the things I made mention of. Now, this is at this level. This level is assembler you have. Yeah, all the work I described for this is at this level, from the assembly language to the machine language, converting what you type from the assembly language into machine language. You need an assembler. But if you are typing from higher language to interact with the machine, you need either a compiler or interpreter. I just realized I've switched them when I got here. Like when you code basically at this level, from this level going, you realize your focus is not on how does the computer interpret what you are doing. You will get back to that if you're someone coding here, or if you want to do, you are here but you are really doing some down deep coding. That is where these things come into your mind. Other than that, you also just to be coding and getting your results, whether the computer is interpreting it, the computer is assembling it, is compiling it. Those things don't come into your mind. So basically that is it. Sorry for that switch. The compiler is actually from the higher level to this, but if you want to convert from assembly language to machine, you use an assembler. But the work I described is basically the same as that. So then here you have either compiler or you use interpreter. How is it spelled? Interpreter, just always ER. Whatever the spelling is, it's like interpreting something. Now they are all converting what you've written to something lower that the computer can understand. Now if I type this, let's see, 2 plus 3 is equal to 5, or let's see, let me see, total salary plus all allowances is equal to gross. Okay, these are two things I've typed, like 2 sentences. Now if you are using, where should I put it? Let's say here. Now if you are using interpreter to convert this one to a language the computer understands, then computer will take this file, convert everything in it. Now it will take, interpreter will take this one, it will take this sentence one after the other. So it will take this one, work it out, then take this one, work it out. If there is a third one, it will take third sentence, work it out. So that is this, sentence by sentence, statement by statement. That is how interpreter does it. But in all cases, remember, it's converting it to something the machine can work with. That is it. If you go down into it, it depends on which environment you are using, or like which language you are using, whether it's Java, it's C++. There are some slight differences in what it is changed into, but the whole idea is you are changing it into a version the computer can understand. And if you are using interpreter, it's line by line. Your sentences you've written, it will take them one by one and interpret it, execute, like do what it's supposed to do. It will take this one, it will add it, it will give you the 5, it will go here, it will do it. So step by step, it will go into what you have written. That is the interpreter. Now if you are to use compiler to change what you have written down to a version the computer will understand, it will take the whole of this one. It will take the whole of this one, change all to version computer can understand. Then before it will start running it, it's like giving the whole difference is one do it line by line, and then the other will convert the whole file at a go. This one will take one line, convert the one line, execute, take second line, convert, execute. So it will interpret it line by line. But the compiler will just take the whole file, compile it before it will run it. So whilst this one that the interpreter is one by one, the compiler does this for the whole file at a go. If you go into them, you realize why maybe some languages uses interpreter, why others uses compiler. So there are, and they have their trade-offs, which I think that is talked about in the book. If you kind of read this once, you get those details and it is. The thing is, if you are beginning with the programming, these things will not be that your focus. If it works, if your environment or like where you are coding is working, then you know the right one has been picked and everything is working. But as you go along, there are the need for you to understand these things, especially assembler. If you are working at this level, second generation, you'll be working with assembler a lot, and you know what assembler is. So that is basically what these things are. And if you read from the book, they have their advantages and their disadvantages. Those are some of the things. So basically that is it for this generation. These are different ways of communicating with the programmer, and depending on the complexity, that is what is breaking them, and within which generation those things came. So that's how they are grouped into this way. So this is what we'll be using: C++. This is what we'll be using: C++. So that is it. Let's move to next slide. This is what we've done. So like I said in the previous slide, this is what we'll be using. And why are we falling on this and not C# and not Visual Basic and not JavaScript? So first of all, if you take C++, it's popular. C++ is very guy. It's like yeah, and you deserve to be guy, because almost a lot of, that's why I wrote here, like almost every application domain, like almost every industry make use of C++ language. If you find people that are like writing things on phone, like so that phones can communicate, if you want to communicate with phone, that one to has its own language you use, but in all cases it's programming. So those that communicate with phones, like programming on phones, you find those that use C++, they use Java. Another one I didn't write, Java deserves a mention here, Java. So Java, the JavaScript, there is Java. Like someone said, JavaScript is not a small Java, so they are two different things entirely. I read somewhere they just got their marketing wrong. When they wanted to come, they realized this guy was popular already, so they try adding this to kind of steal their marketing already, but it didn't work. Up to now, people sometimes only think this one is a small version of this. No. So that is C. Why we are picking it? Almost every, if you find those people that are writing softwares for big machines, you are likely to find C++. Those and drivers, hard disks. If you want to write something so that hard disks can run fast, if you want to write something that the memory can be big, these are things, or like things that communicate with memory. Almost everywhere C++ is there. That's basically what I mean by application domain. If you want to be like a drive programmer, like pen drives, they have their drivers. Digital camera, they have their drivers. Keyboard, you have drivers. Everything you communicate with your, like you connect to your computer, it has its own drivers. And C++, you can find your C++ there. And most institutions use it. It's not surprising Kenya still is using. It is so difficult to, not just Ghana, globally. If you've been watching, let's say Harvard videos, let's say Oxford or MIT, Stanford, all these, they use it. so it's widely used. And me personally, one thing I also like that makes me like C++ is the how the language is similar to other languages. It's like that is the mother, and people try to steal how they look. It's like maybe if you take let me take a local language. For example, let's say in Ghana there is if you take Bono language, there is or let's say Chi. So Chi, there can be like there's Bono language, there is let's say Infante, there is Asante, and there is Equiapem, there is you see all these are different languages, but if you are able to understand one, it's easy to pick up the others. But if you take, let's say, Bono, or let's say in Ghana, if you are in Ghana and you are learning, let's say, Chinese, you can understand Chinese alright, but you can use Chinese basis to easily understand, let's say, Bono, to easily understand, to get. So that is the whole thing. So if you know C++, it's so difficult, like easy to understand other languages like Java, because the language is how to say go basically the same way. You say it in C++, the same way you say it in C#, maybe slightly different way you say it in Java, or how you put your full stops. So small just differences. But if you are okay with C++, you are fine with you can easily pick up with other languages. So basically that is it for this one. And other things to I've realized mostly those that do C++, they are guy. But that's what I've realized. In the languages that you can communicate with the computer, I don't know if it's a perception or that is the reality, but I think it's the reality. C++ seems to be a bit challenging than other languages. So if you're able to crack C++, there's that hope you can crack you can understand any language. Let's say if you take normal language, you say, hey, Chinese is difficult. So if someone is able to master Chinese, so you don't speak Chinese, you're able to understand Chinese, then you know, oh, so far as I've gotten it, then all other languages I can. So basically that is the flavor with C++. And then if you also want to know a bit of what C++ is, its own history, we've gone through the history of the programming itself. That's it here, and then a bit of the C++ developed by this guy. Let's see who is he. He developed what he was at lab, Bell Lab 79, BJAR MESTRASSTRUP. So let's see where he's working now. He's not dead yet, he's still alive. I don't need this, I need this. You want this spelling? Think of making it good. That's the guy. That's him here. He developed the C++ language. In normal language, I think it's difficult to say. For example, if you say who brought English language, that is difficult to say. But in programming language, you can say it. You can say like who initiated that idea. You bring it by the point in time, one person, you can't manage that language again. You will have to get a team on board, and then it's like there will be a kind of a body that will be in charge of that language. So they will be able to tell you, this year we are adding let's say comma to the language. This year we are adding this another word that will mean go, just like how English language is. If you check in Oxford Dictionary 2018, there are a team that normally add new words. So this era of social media, occasionally words are added. The same way in programming too, there is a team in charge of it. So occasionally new words are added. so that you can speak well, you can speak the language well. So this is the guy behind the C++ thing, and then this is his site, programming language. He's a Danish, born doctoral advisor, and these are the awards he's gotten: University of Cambridge, blah blah blah. I'm just laughing. Coach wrote that C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do it, it blows your whole leg off. Now there is this between C and ++, like how the name came about. No, there is a language called C, a programming language called C. For now, we know what programming language is. So there's a programming language called C, and later C++ came. So it's like more of C, so plus plus, like addition. More has been added to C. So like I was even saying earlier, if you know C++, anywhere you can add on your C that you know C, because there are just few things you have to check to know the difference. It's just a build upon of C. It's just a build upon of C. So if you know C++, automatically you know the C. That is or more it will take you like a week to be able to switch to speak that language, the C language. So that is it. And then that's here. It was originally called C with classes. We go into what classes mean. Like it's not like P1, P2, P3 classes. No, but we can have things like this is the upper class. Like these are the rich guy. They have their own class. These are the yo-yo guys. They have their own class. These are the wee guys. They have their own class. So that type of classes. There are that concept in computing, like in programming. So that is the original name, and this is a little bit of it. It's called multi-level for a reason that if you want to C++ is called multi-level. It can behave like a lower level, it can behave as a higher level. Like you can use it. This, for example, this one is used if you want to write things like drivers. If you want to write drivers, you really have to master this. But you can do it with C++ too. So you see, in that case, you go low to the computer. So it's multi-level. It can behave as a higher level language. It can behave as a lower level language. So it's good. It has that upper hand. So that is the concept of multi-level I made mention. In general purpose, you can use it to write different softwares for different industries, like for accounting software, for military softwares, for let's see, like that's a different field, different field, like scientific, physics, different fields. So that is the general purpose. There are some languages that are good for certain things. Let's say you say R. There's a language called R. These guys love it. Data scientists, like for working on data, R, they like it. So you can say that one is not multi-purpose. So that is basically what that one is, and it's supposed ANSI standard. What I mean ANSI standard means there are just guidelines that helps you. If you do things in, let's say for Windows, you'll be able to do that same thing. You'll be able to in different environments, like let's say Linux or in Mac, so things like that. That is ANSI. If what you are doing support ANSI means you can easily port it from one environment to different environment, like Windows environment to Mac OS to different environment. That is the NC, and it's case sensitive. This is very, very important. Very, very important. Let's see something here. Now, in computer, not just in C++, anywhere you go, if you okay, anyway, we have a particular example already. Password. If I give you a password and say it's case sensitive, what it means is if the password is Kawunda, you can't write it the K capital. If you write this, you are wrong. If you write, then you make this one, you are wrong. So if what I give to you is small letters, make sure you type everything small letters. If you make it, you are wrong. You are wrong. That is just what case sensitivity is. So anything you are writing in C++, if what you wrote them in small letters. If you want to make reference to what you've written already, make sure you write that in small letters. If these are different things. That is just all what case sensitivity is. And like one guy said, it's very important if you bend this into your brain. C++ is case sensitive. C++. There are other languages if you are learning, you can say come, and that will mean the same as this, but no. If you say come in C++ and that come you wrote it in small letter, it's different from saying come in capital letters. So that is basically what case sensitivity is all about. So this is where we are. Now we are going here, which is environment setup. This is simple. Like we are basically talking about where do you write the instructions to communicate with the computer. That is just all. Where are you writing the instructions so that you can be communicating with the computer? That is just all. That is just all. And you can group them into two. There are environments you will find online, and then there are environments you will find offline. Mostly all environments you will find online, the dirty work has been done for you already. You just go there and start. But if it's offline, then you will have to do all the dirty work setups to set all things up yourself before you can use it. So let's see an example of the online, which is the site cpp.sh. Okay.
102, then say 1002. This media. UPS media.
The name of the UPS is labeled.
Fridge. LG. UPS.
Come on.
It's Mazma.
Then?
Mazma, top 5.
That's your PC down.
The PC is
Dell what? Here is going to pretend to
cool.
I'm beginning to okay. What's easy?
Fun, orange. SBS. Look at where it is on Strawberry.
Optiplus 9010. Dell Optiplus 9010. It's i7.
i7. 2010.
Yeah, Dell Optiplus
2010.
9010.
2010.
Yes, that is the module.
Yeah.
Optiplus 9010.
Printer.
And the printer is LaserJet CP1025 color HP.
I double line or something.
CP 1025.
CP 1025. Color.
Yes.
Yeah, this one is the music.
Print and wire.
So much.
Me the penny on one. They would and a China made China 244. If you know bright, print and wire.
Yeah, he's done it. You know write papers?
Yeah, papers to image.
UPS no way.
Maximum.
Sorry. How do they call this? Is it embossing or what? They are labeling the items. So let's move on. Now let's look at the environment again. I made mention there are two: the online and then the offline. Online, everything is set up already, so you just have to start communicating with your computer. Yeah, it's like speaking English with someone. And the offline, you will have to put all the tools you need. You have to install them. So let's go to one of the online, which is cpp.sh. So cpp. So I have to change my cable. So cpp.sh. This is not cpp party. This is not cpp party. So basically here you've come. A bit of some nonsense there already. So let's say you just come here and then you start communicating with your computer. That is all. That is all. So that is it. That is it. Now if you want a small example, we can change here. Don't worry about what I'm doing. I will come back and start. If I do 3 plus 5, now you run it from here. See, that is the answer down here. That is the answer down here, 8. So this I've typed it. That is the answer here. So I've just communicated with the computer, and this is it. I've typed it, and then that is it here. So to be able to answer to 3 plus 5, that means you have to type all these plenty things, all these plenty things. What is this one? I'm supposed to, let me see if I take this out. Okay, so you can't do undo to second level. So let me do some small thing. So we have let me see something here. So in this case, if I take this one out, so that is it. I'm just testing. What we are interested here is, you see, I've come online. I just have to type the site and then bam, I'll just start communicating with the computer. There's nothing to worry about. Now if we come here, this side should be the same. It should be the same. It will open something and then bam, you just start typing things there. You don't have to install anything, just straight away you are going. That is the online. Now if you are going to offline, you see that is this one to the same thing. Testing, is it mic 1 2 3, down to you test it here. Yeah, testing mic 1 2 3. So if I say 3 plus 2, that is the answer here, 5. So I've communicated with the computer. Yes, of course, if I can use calculator here. 3 plus 2, what have I done? 2 plus 2 is equal to this. So that is it. But what you have to remember is someone did this and that person is a programmer. So if you are using, that doesn't make you a programmer. You have to learn how to do your own calculator or whatever you want to do. And that is the steps. This is some things you'll be writing that will also help you do things like this. So that is it. So that is the online. You've seen this, we've seen this. Now let's see the offline. Now if you want to do the offline, this place we are typing, this place we are typing is called test editor. So the online is providing us test editor, and the online is providing us with compiler that will convert what we will write, something like total salary plus allowance is equal to gross. So online platform is providing us with the IDE, that is basically where we will do the typing, and it's also providing us a compiler where that will convert what we've typed to the answer we want to. So literally these two things are very important. So if you have to go offline on your own machine, where if you don't even have internet you can be practicing, that is one disadvantage of the online. You should know that you only have to do it online if you have internet access. But if you want to be able to do it at your convenience, you don't have internet, then you have to go for the online. Now to do the online, to do the offline, then these two things have to come to your mind. Test editor and then compiler. These two things you have to install. So let's continue. That's, you can see them here. We have this one, test editor, and then compiler. Test editor, there are a lot of them. You can even use Notepad. You can use this one to type. But what you have to know is your test editor should not have formatting. It should allow you to save things raw. No colors, no like bold, no like underline, no like. You should allow you to save things raw. That is what you want. So Notepad is a typical example. And if you go under compiler, these are different compilers. It's difficult trying to go through what these ones do, which one should we pick, and those things. The more you do, you know your own preferences. But for now, let's understand that this is what will convert what we are typing to that version the computer can understand. That is what the compiler is doing. If you look at the graph, the diagram we have here, the compiler is converting what we are typing to a version the machine can work on. So basically that is it. And straight away what we'll be doing is we are going to use this compiler. We are going to use this compiler, and the text editor we are going to use. These are some examples of the text editors. These are examples of the text editors. Visual Basic, Code Blog is a text editor. Ellipse, Microsoft Visual Studio. Okay, and then Qt Creator, Code Light, C-Clean. This is what I'll be using. This is what I'll be using. Now, these ones are called IDE. These text editors are called IDE. They are called IDE because they are integrated. They don't just have where you will type. They have where you will type, and they also have the compiler in it already. So you just have to download, install, and you are done. You've gotten your text editor and you've gotten your compiler automatically. So this one that I'll be using, it has this compiler in it already. It has this compiler in it already. So if we install this, we've gotten both of the world. So that is what we are looking at. So these ones are called integrated development environment. Integrated development environment. Yeah, that's IDE, and you can just see them as takeaway food. You know, if you just go out and download and install, it's like going to buy takeaway. You didn't prepare, you didn't do anything. You just go, your meat is in already, your food is in already. They might even give you a water in the, they give water in the polythene. So everything is packed already. So if we install any of this, everything is set already. So that's why we're going to use IDs, integrated environment. Integrated development environment. That's what we are going to use, and what I'm going to use is this. This is my favorite. The reason why I'm going to use it is light. It's very small, and I've said it earlier, it also comes with the compiler, what you convert what you type into a version the computer can work with, and it's free. So not like giving free, it's open source. So that is basically why I pick it, and can do all we need to do. So basically that is it for the introduction. So next one, or let's just see the installation. So that next tutorial we just go straight to so dev C++. There are different sites you can download from the Blasher.net, File Hippo. What is funny is one guy, there was a time he said something like that the words programmers use are scary. It's like it makes them look like evil guys. Now look at the site, you have to download something from bloodshed. So I feel like they are shedding blood there or something like that. So he actually gave a series of words which I started to realize, well, these words are dangerous, but if you are in the programming environment, you realize it's common. It's common. Another typical example, if see here, if you want to test what you've done, then you say execute. But that is crazy word, execute. Execute. So that's what came to my mind and laughing over it. So that is what we'll be using. This one. There are so many sites you can download from. File Hippo. Let me see, File Hippo. I actually download a lot of things from File Hippo. That if they have it, that is my first place I go to download things. So that is just, you download and you install. That is it. You are done. Just download and install. That is it. You are done. And the size is small, 48 10 megabytes. That is the site, and these are the features. You get all these things for free, so you can read more about it also. These are the features here. You have this, all this compilation. So that is what we'll be using. We will not go through the installation, but this is where you have to come. File hippo. I have it already. So the step is so simple. Just install that download install. That's all. You've already gotten your text editor where you can type it, and you've also gotten your compiler in it already. So let's go to new file. That's it. So just start typing. So now let's see something here. This one, let's just copy this one and then put it here. And then now instead of the execute here, that one is here, and it's called compile. It's called run. So you run. You have to save it first. So and you save it with the extension of CPP, C++. You know, if you are working with Word file, you will save doc, DOC or DOCX. If you are working with Excel file, you know the extension is XLS or XLSX. So dependent. So this one too, you have to save it any name.cpp. So you can begin with any name. You can type any name, but you have to save with CPP. I'm putting it in quote. Sometimes the Windows behaves some stupid way. You type something and it will add its own extension. But to make sure, then hey guy, don't add any extension to what I'm saying. I'm serious about what I'm doing. In that case, you put it in quote, so it will not even dare to add any extension to what you are doing. Other than that, you might think you've given your own extension, but the computer will kind of some stupid thing. I don't know how it does it, but it will do that thinking, and then it will add your extension. So you realize yours will not work. So I'm saving into this folder, and then that's it. So it's saved. So this is the answer 5. That same 5 we got here. That is the same 5 we are having here. The good aspect with this is you can even work with this if you are offline, if you don't have internet access. So even when you go home, you can, wherever you are, you can. So basically that is it. We've gone through the steps, we've gone through the basic. It's that is it. We've seen what programming is, and we are going to use C++. So that's why it's called programming with C++. I've said earlier, the object-oriented, we will talk about it later, is something big in every program, like any of the higher level programming languages. I hope now you're okay with the terms if I use them. If I say higher level, you know what it means. They are the type of programming language, if you write, you will need either a compiler or an interpreter to convert it to whichever version the computer can work with. So that is it. Now in brief, if you say object oriented, what you are trying to do is approach programming like you are approaching real world things. Let me just put it that way. Approach programming like you are approaching real world things. Let me just put it that way. How real world behave, approach programming that way. So that is in short, but we'll be going more into it and see how real world things behave and what you have to do. We've seen the course things too. These are the key things we'll be using: Shape, Google, and then that PDF, and then this online tutorial. So, and we've seen what programming is, what we program software. We know programming language just like another language we've learned, like P, English, French, but this time, this language you are learning it so they can communicate with computers, with phones, and with other devices. If I say communication, not like installing things, no, that thing you are installing, you now want to do it. You now want to do that thing people will normally do and you will install. You know, you will now want to do your own. So, and just like how English has its rules, how P has its own rules, that language you are going to learn to communicate with the computer also has its own rules. And then we went through the history. First generation where you're using the zeros and ones, the second generation where you're using things like add, subtract, divide, like which in some I call mnemonics, which US has its spelling, UK has its spelling. And at that level, we are working directly with the computer's processor and the memory. So things you do for the processor A or architecture A, you can't just use that same instruction to communicate with the computer that has architecture B. It will not work. So you have to narrow down to know which language you're using for which architecture. Then you come to the level 300 or like the higher level, third generation. That is where C++ that we are using. That is where it's found. And like I said earlier, the higher you go in the languages, the more closer you come to writing things that are closer to human understanding. Things that as soon as you write it, someone can look at it and know what it is. The higher you go, that is how the languages are evolving. So then why we pick C++, we've gone to, it's very popular. Almost a lot of things use C++. Devices use it. You can use, if they make efficient use of memory, so it's good to use it for device drivers, or if you want software that will communicate with drivers. Most institutions use it. Most institutions, universities, technical universities, and both in Ghana, outside, they use it. And the language format is similar to so many other languages. Actually, a lot of other languages borrowed from C, and C++, C++ also borrowed from C. So if you know C++, it's like automatically you know C. Like they copied C directly and added something called like the object-oriented, which I've talked on earlier. So initially it was actually called C with classes. So C with classes, and this is a bit history of the C++ we've chosen to, and we've gone through the environment. We know there are online and there are offline. We've tested some of the online, now we've gotten our offline. These are other examples of IDE, which I'm calling takeaway food. I'm calling them takeaway because as soon as you install, you get everything alright. You don't have to configure any compiler, you don't have to do any settings in it. As soon as you install, that is just one. This is the one we'll be using for it, and hopefully that is it for this. And then I'll upload it right away, and then maybe today or tomorrow we'll see if we can go through. I think it will be good to add the date to the slide. Today is January 23rd, so this is actually the date, and I'll try and upload it today. And then so hopefully I'll see you next time in 2, and make sure to comment on YouTube, and then anything that is not clear, you make us know. And then bye for now.